This section is going to be about logarithmic functions. This is section 3.2 in your textbook. The essential questions we are going to answer in this section are, what is a logarithmic function and what is its equivalent exponential form? What are basic logarithmic properties and how do you graph logarithmic functions? We'll start off with the definition of the logarithmic function. The logarithm of a number is the exponent to which another number must be raised to produce that number. To repeat, the logarithm of a number is the exponent to which another fixed value must be raised to produce that number. Or to put it mathematically, y equals log to the base b of x is equivalent to b to the y is equal to x. Okay, those two expressions are equal. The one on the right is the exponential form. The one on the left is the logarithmic form. Now I could plug in some numbers and say that 2 is equal to log to the base 5 of 25, which is the logarithmic form, and I could change that to the exponential form, which would be a little bit easier to understand, and that would become 5 to the second power is equal to 25. So the exponential form, you can see, is fairly straightforward. If you square 5, you're going to get 25. Well, the logarithmic form of that same expression is 2 is equal to the log to the base 5 of 25. Those two expressions are identical, okay? They're just two different ways of writing the same thing. So now let's look at some basic logarithmic properties. Now the first of these simply states that the log to the base b of b is equal to 1. Now if you go back up to the exponential form, all we're basically saying here is that b to the 1 is equal to b, which is obviously a true statement. So the log to the base b of b is equal to 1. That's the first property. Now the second property we have states that the log to the base b of 1 is equal to 0. Well, again, if you go up here to the all we are really saying is that b to the 0 power is equal to 1. Again, looking back up at the exponential form. The third property is that the log to the base b of b raised to the x power is simply equal to x. Again, if we go back up to the exponential form and we convert this to that, we get that b to the x is simply equal to b to the x. Now the fourth and last property that we'll talk about right now is that b raised to the exponent, where the exponent is log to the base b of x, is simply equal to x. Now if we take that, which is the exponential form, and convert it back to the logarithmic form, we will see that log to the base b of x is simply equal to the log to the base b of x. So all of these properties and everything we've talked about is based on the definition or the equivalent expressions, that whenever we've got a logarithmic expression, log of base b of x is equal to y, that's equivalent to b to the y is equal to x. And if you keep these in mind as the logarithmic form and the exponential form, and the fact that you can switch back and forth between these since they're equivalent, you can better understand the properties and how logs work. So now let's look at some of the characteristics of logarithmic functions. Now remember that y is equal to log base bx is equivalent to the exponential expression b to the y equals x, okay? So make sure that you remember that in all of these characteristics because it helps to explain them. The first characteristic is that the domain, or x, is all positive real numbers, okay? So anything greater than 0 all the way up to infinity. The second characteristic is that the range y is all real numbers. It can be either positive or negative. The third characteristic is that the graphs of all logarithmic functions pass through the point 1, 0. Now, given these characteristics, and if we were to plot some points, we would find that a typical log function is going to look something like this, where this point here is x is equal to 1. It always crosses the x-axis at x equals 1, and it rises to the right slower, at a slower rate, and it falls down to the left. Now, the y-axis is going to be a vertical asymptote here. It's going to get really close to the y-axis, but it's never going to equal it. Now, the last thing we want to talk about is that typically in most applications, the base for logs that we use is either one of two things. It's either the b or base is equal to either 10 or the letter e for. If it's 10, it's considered common logs, log base 10, and we normally don't write the value of b in. It is just written as log x, which implies log base 10x. Or it's the base is e, but instead of writing log base e of x, we write ln of x, and this is shown below. Now, I want you to use the formula r is equal to the log of I divided by I sub 0 to solve this problem. If an earthquake is 10,000 times as intense as a zero-level quake, in other words, I is equal to 10,000 I sub 0, what is its magnitude on the Richter scale? In other words, what is the value of r? Post your answer in the drop box.